Why did you want to be an astronaut?
Well, I know the day that I was inspired to be an astronaut, and that was July 20th, 1969. I was 7 years old in Michigan at my grandparents' house, watching a black and white TV with my brother and sister and parents. And we watched with great interest on a fuzzy black and white TV as Neil Armstrong stepped on the moon and made his first speech as he stepped on the moon. I looked at my brother and sister. I was 7, my brother was 9, my sister was 11, and we were amazed, and I said, wow, I'd love to be an astronaut. So that was kind of the bit that was set way back when I was 7. And I remember that actually when I talked to kids, how a small milestone, a very short event can have an incredible impact on somebody's future. That being said, I thought it was just a dream. I didn't really believe that it could ever happen. But I worked hard in school, loved math and science, became enamored with airplanes and rocket ships, decided to get an engineering degree, went to the Air Force Academy because I really wanted to fly, but I also wanted to fly to be a better engineer, better understanding of the physics and the operation of space vehicles and aerospace vehicles, airplanes and spaceships. And so then got involved in the flying thing, and of course, flying is great, and I've loved my flying career. Flew fighters, went to test pilot school because that kind of brings the engineering side back into the flying. It was kind of a rebirth about 10 years into my career. And at that time, I realized that, wow, you know, I'm flying really cool stuff, and they like to hire test pilots because each shuttle mission really is a test flight. And so went ahead and threw my name in the hat. My goal was to get an interview, to come down, meet some astronauts, blow the ping pong in between the lines, you know, do those sorts of things. And so, of course, unexpected and very excited to get picked into the class a dozen years ago.
Let me get you to tell us where that whole story began. Tell me about your hometown and your growing up and what it was like for you there.
Well, I kind of have two hometowns. I'll start with the hometown in Fairborn, Ohio, because that's where I ended up junior high and high school. I was a military brat, and we moved all around. I was born in the UK, and then we moved all over the United States, ending in Ohio when I was a senior in high school. And so I had amazing teachers in high school. I had just support of my mom and my dad and my siblings. They used to tease me that I was like peanut butter because I was spread too thin, because I was involved in so many different activities. But I was always trying to do the best I could in every activity. I was greatly involved in music, and my dad was a musician, my brother is a professional musician, and so I really got into the band, various bands, rock bands, high school band, you know, marching, concert, jazz, and my band leader, Mr. Bob DePiro, he was a great mentor for me, kind of rubbed some rough edges off of me and taught me discipline and different things, and excelling in whatever you're doing the best that you can do. And so that, if I could characterize my high school years growing up in Ohio, it was just trying to do the best that you can do in everything that you're doing. And that kind of set me up for going to the Air Force Academy, which is kind of, you do a whole bunch of things at the Air Force Academy. It's not just about academics, it's not just about physical fitness, it's not just about discipline, it's kind of all three. And so that was a perfect match for my college years.
Did you get a chance to get a good look at Fairborn, Ohio, or Colorado Springs when you flew?
Well, Ohio, you know, is south of Michigan. The hand is really easy to see, and the Great Lakes. And then you've got the Ohio River. But picking out, I looked at Dayton. I could see Dayton, and I knew about where Fairborn was in relationship to Dayton. I think I saw the triangular runway at the Wright-Patterson Air Force Airfield Area B. But it's a lot of the time on my last space shuttle flight, we were flying over the U.S. at night. So it's a little bit difficult to see. Now, my second hometown is Traverse City, Michigan. And that's where that was my dad's permanent home of record. It's where my mom and dad met. And it's been kind of the summer and winter recreational ground. We had a lake house up there, and my grandparents lived there, and it was the warm homecoming place that I would always go as a kid. And in fact, I still still share a lake house up there with my brother and sister on that same location. And so that was a lot easier to see because Traverse City is right at the top of the hand, and there aren't a lot of bright lights up in northern Michigan, so I could clearly see Traverse City, and I honestly, with the moonlight, think that I picked out Long Lake, which is where the cottage sits. And so, you know, when I think of two places in the U.S. that bring me that kind of homecoming, hometown feel, it'd be Fairborn, Ohio, and Traverse City, Michigan.
You touched on this before. Let me get you to expand a bit on the path from high school into college and your Air Force career. Tell us those steps that you took that ended up you becoming an astronaut.
Well, I went to the Air Force Academy, of course, got a degree in aeronautical engineering. Went on to get a master's first, kind of did that, filled that square first, because I knew once I started flying, it might be more difficult to get a master's, and I wanted to get a good master's in residence, so I did that, and then went off to fly. I went to Lubbock, Texas, at Reese Air Force Base. It's since been closed. And I trained in the undergraduate pilot training in the T-37 and the T-38. And lucky for me, they decided to keep me as a T-38 instructor for 3 years. So I taught guys to fly for 3 years in Lubbock. That's where I met my wife, Carrie. And we were married at the end of that tour. And then I got a fighter out of there and moved her out of state to North Carolina. In North Carolina, I flew the F-15E. Desert Storm hit about that time. And so I had a couple deployments out to the Middle East, and then finished that tour applying to test pilot school. At which time I went out to Edwards Air Force Base, tested the F-15, and chased some other test programs. But one interesting test program I had out at Edwards was the active advanced vehicle technology. I can't tell you the acronym, but in any case, it was a thrust vectoring. Flight control kind of integration test program that was going to be used for the Joint Strike Fighter and follow-on vehicles. Similar to what we're doing with the DTO for the rendezvous for the follow-on vehicles, same sort of thing. But a really exciting program, a lot of different agencies involved, including NASA. And I believe that probably my interaction with the active program at NASA Dryden was in California at Edwards was one of those connections in the networking that gave me a little something that, hey, I've worked with NASA, I've done this really cool test program, and we did get some awards for that test program as well. So that was one of my feathers in my cap for maybe having a chance to apply for NASA and be selected. Went to a leadership school after that. They were heading me to the Pentagon. And about that time, I threw my name in the hat, came down for an interview, and came here instead. So instead of going to the Pentagon to my first non-flying desk job, I went to NASA.
You talked about going into the Air Force Academy because you were interested in flying. What I didn't ask you is, what got you so interested in flying?
Well, I did a little bit of flying in high school, but I've just always been inspired and excited about airplanes. I remember the first time that I flew an airplane overseas when it was about when I was 7. It was '69. We saw the first lunar landing, and then my dad was assigned to Germany, and I flew on my first airplane overseas, at least the first one that I remember. I guess I must have been on airplanes before that. But I was looking out the window at the clouds, and I was just amazed at how the thing could fly. And that was always an exciting topic for me. I was always asking questions about it to my parents, trying to understand it, paying attention in physics class in high school. It still amazes me when I go out and fly the T-38 and I look at those little short, skinny little wings and that thing's flying. It's just amazing to me, even now.
Now you're in a career where the flying in space part of this career is one that has got some significant possible dangers to it, a lot more than most people have in their jobs. So Greg, what is it that you think we're getting as a result of flying people in space that makes it worth taking that risk?
I don't know that the risk is any different than driving in and out of Houston every day, but I'm kidding. But yeah, I think the risk is well worth it because we are an exploring country. We're a leading edge technology country. And I take my parenting very seriously, and I talk to my kids about being the lead dog, and if you're the lead dog, everybody else is looking at the tail end of the lead dog. You know, you want to be the lead dog, not the guys behind. And we've been the lead dog. And the reason we've been the lead dog is because we take those risks, that we push technology and exploration forward. And the space program is a perfect example of that. And the technologies and the capabilities that we get from the space program and the economies. I mean, the economic impact is a little bit intangible. But if you really go back and look at all the various spin-offs and things that we've gotten from the space program and how it's impacted our country and our world, space is that next frontier that we need to explore. And so I think it's extremely important to be involved with space, and I think that we don't spend enough. I think we should spend much more on our space program than we do these days, but I know times are tight. So any risk to me personally, I think it's well worth it.
You're a member of the crew of shuttle mission STS-134. Greg, give me a summary of the goals of this flight and tell me what your job is.
Okay, STS-134, we are an International Space Station assembly mission, one of the final ones. We're taking up a very important experiment, the alpha magnetic spectrometer, a science experiment that could change the course of physics. And we're also taking some pieces and parts up to the space station in anticipation of the shuttle retiring, because we only have a few more shuttle flights. And so we're taking those parts up in an express logistics carrier and perching that on top of the space station as well. I'll be the pilot. We have 4 mission specialists doing 4 spacewalks. We have a lot of robotic arm operations, and so I'm kind of the head arm operator overall, overseeing what we're doing with both the shuttle and the space station robotic arms. And I'll be taking part in both sides of that endeavor, moving the robotic arms, moving the pieces and parts around, inspecting the shuttle prior to re-entry and after launch. And I'll also be the pilot, sitting in the right seat, so I'll be monitoring a lot of the shuttle systems, as well as doing different duties aboard the shuttle, looking over the toilet, for example. That's one of my jobs. I'll be making sure that everybody gets their meals and those sorts of things. I won't be doing any spacewalks, but I will be back in markup as kind of the other pilot on board.
Almost everybody on this crew has been to the space station before. In fact, 2 of your crewmates have finished long-duration missions on the station. Has that kind of experience paid off for you guys as you've been preparing for this flight?
Oh yeah, absolutely. I mean, everybody on our crew has kind of a unique experience base bringing to this crew. And we all have very different backgrounds. And like similar to my last flight, a whole bunch of different kind of personalities, but you put them all together and synergize as a great team. Roberto from Italy, I'm really looking forward to him. We trained as astronaut candidates way back a dozen years ago. And then we've got a couple guys who have lived on the space station for 6 or 12 months. Mark Kelly's a very experienced pilot. I've been working with him since day one. And it's an honor to serve as his pilot on this mission. And then finally, Drew Feustel, who's one of the greatest spacewalkers. He's been to Hubble, and so he is kind of heading up the spacewalk team. So pretty much the whole crew is a very experienced and very dedicated member of the team, and I'm looking forward to working with all of them.
Let me get you to tell us some about the cargo, the things you're delivering. What is Express Logistics Carrier 3, and what does that do when you get it to the station?
Well, it's a big pallet that basically holds a bunch of stuff that we're taking up to the space station. The carrier itself goes as one object. So when we get up to orbit, and which is interesting, once we attach to the space station, we're going to say hi, we're going to get some safety briefs, and immediately we're going to get to work on that very first flight day, because we want to get those heavy cargo items out of the shuttle. That's the highest priority. And so the AMS, the alpha magnetic spectrometer, and the ELC are both very important, but the ELC happens to have a CG impact, so we're taking it out first. So we're doing that on flight day 3. And Roberto and I believe it is Spanky, Mike Fink, are operating the shuttle's robotic arm. They're going to lift the ELC out of the shuttle and just kind of hold it out in space. And then Taz and I are going to use the space station robotic arm, grab the ELC from them, and attach it onto the space station. Taz and I are doing both of those handoffs from the space station robotic arm side. Taz will be the primary operator, and I'll be backing him up with ELC, and then we'll swap roles for the AMS.
Is that all it takes to install this thing? Just to, if you will, simple plug-in?
Yeah, it's essentially that's what's going on. We have some robotic maneuvers to get there, and the handoff it has to be precise. But those guys have done a great job in the simulation. We've done a full simulation from it being in the cargo bay all the way to where we're going to hand it off, and then we attach it. And then once we get it up there, there's also another process to get it physically attached to the truss. And Taz and I are both going to do that job as well. For the ELC, he's the primary arm operator, and I'm the primary claw guy, and then we'll swap roles for the AMS. But the whole operation will take maybe 2.5 hours, I imagine, for the whole thing. So it won't add a whole lot of time to the rendezvous day, but the rendezvous day, of course, is a really long day.
That attachment, then, is something that you guys do from inside?
Yes, we do. It's all computer-based, and it'll be interesting because we've got the two Gregs doing those two different things, backing each other up. So there's going to be some humor on the loops, I imagine, as we do the comm protocols, handing it off to each other.
ELC is being delivered with some spare parts on it already, right?
Yes, one of the spare parts that's on ELC is the SPDM, an SPDM arm. And I have close to my heart the SPDM because we took the SPDM on my last flight and assembled it on orbit with a lot of spacewalks. So we're taking SPDM arm and parts up there, as well as some other items.
The second big payload you've got, you mentioned before, the alpha magnetic spectrometer. Tell me what that does once it's installed out on the space station's truss.
Well, the alpha magnetic spectrometer, or AMS, has been a project that's been 15 years in the making. I don't know how much money and how much manpower has gone into this thing, but I know a whole bunch of smart guys, including a Nobel laureate, have been involved. And so the AMS is really exciting. And it's one of those kinds of experiments, one of those rare kinds of experiments, that it really might just open some new doors that we never even knew existed. It's a particle detector. It measures, it collects various cosmic particles that can't come through our atmosphere to Earth. So this particular experiment can't be on the surface of the planet because you can't get the kind of data that you can out in space. So the first thing, it needs to be out in space. It needs to be stationary. It needs to be zero gravity. It needs to be undisturbed and collecting its data. And then the particles are going to come into the thing, and we're going to get signatures of those particles and then learn about those particles. One of the things we're studying is dark matter. We're going to try to look at naturally occurring antimatter. But there's also other particles probably out there that we don't even know exist. And so that thing, I expect the AMS to discover new particles that we didn't even know existed, and possibly will open doors in particle physics.
Give me a sense of the importance of what it may find. I mean, they've described this as looking for data that can help understand the origins of the universe, which is frankly a pretty big deal.
Yes, and you know, as we press forward in technology, we learn new things that we didn't know. The Hubble telescope, for example, looks so much into the past in our universe that we actually visually can understand some elements of the origin of our universe from Hubble telescope. This is a particle detector, so it's not on the visual spectrum, but it's cosmic particles in the other of different sorts that this thing is collecting. Naturally occurring antimatter, dark matter, a very big question out there, trying to understand what this dark matter is and where it is and accounting for it. And those sorts of particles are going to be collected by this particle detector. And then the very smart people that understand all this stuff are going to put it all together and learn new secrets about the origin of our universe and a lot of other things. You know, whenever there's an experiment like this, that the goal is to, for example, learn about the origin of the universe, what history has told us is when we have these sorts of experiments and explorations that we learn things that we didn't even know were there. For example, the Lewis and Clark expedition. They went to go find the Northwest Passage, and yet they didn't find it. And they were way over budget, by the way. But they were an amazing success because of all the other things that they found that they didn't even know were out there, the unknown unknowns.
You're not going to find out any of these things until you and your crewmates get it installed. Tell me how you go about putting AMS, taking it out of the payload bay and putting it on the truss.
Well, part of the problem of AMS and ELC, for that matter, both of the tasks are very similar, and as I said before, Taz and I are going to be working together, getting it in place and then attaching it. It's on top of the truss, and a lot of the assembly of the space station was using cameras that are on the bottom portion of the truss. So when we get up to the top of the truss, there aren't a lot of good cameras up there. So it's a little bit challenging trying to get good visual views of where we're putting the thing. The shuttle robotic arm is helping us out. It's going to reach out and look at a certain angle that helps us. It's kind of like a remote camera, if you will, that'll be helping us, and that'll be a primary view for us as we attach it onto the space station. We're also going to move very, very slowly. And so once we get it into place, there's 3 V guides with claws, and actually a big claw that grabs it in the middle, and we'll just basically stick it in place, and then the claws will close around it and attach it onto the space station.
This mission also has a plan for 4 spacewalks to be conducted by 3 different pairs of your crewmates going outside. What's your role going to be while your crewmates are conducting these EVAs?
Well, I'm going to make sure they're well fed prior to going out, and I'm going to make sure they're well fed coming back in. No, I'm just kidding you. But that is a very important part, and I didn't really realize how important it was on the last flight that I went on, where we had 5 spacewalks. Those guys get really tired, and the 4th spacewalk, the meal is probably going to be the most important thing on their mind once they get in. They're tired, they're hungry, and they're ready to relax. But during the spacewalks, EVA 2 and EVA 4, I have a robotic operation part in that. For EVA 2, I'll be holding on to the SPDM, and Drew is going to lubricate some of the end effector, the portion that grapples onto a grapple pin. He's going to lubricate some of those snares. Holding Mr. Dexter, the SPDM, he's a big object, and so moving him around as we lubricate him is going to be an interesting proposition. We're not able to practice that in the pool with 1-for-1 geometry because we can't grab an SPDM and move it around in the pool. So we use this little rinky-dinky, I call it son of SPDM, that we use to practice it. But we do get to see the geometry in the virtual reality labs, so we have seen how it's going to work. But it's going to be an interesting exercise once we get up there. But I'm sure it'll be fine. We've got a good plan, and it'll be a success. For EVA 4, we're moving the OBSS, the boom, and attaching it on top of the truss. Spanky and Taz are the 2 that are going to be up there accepting the boom and attaching it. And then we're going to modify the grapple fixture attached to the boom. I did get to do this particular robotic operation on my last flight on STS-123, so that's all I do, I guess, when I go up is attach booms on top of the space station. But we'll be doing it again. We learned from some of the things we did on the last flight for this exercise, and we'll be handing it off to them. They'll attach it to the top of the boom, top of the truss, and then I will meet Taz over toward the more center section of the space station. He'll get on the robotic arm, and then I'll be moving him around on the robotic arm, doing his work, replacing the grapple fixture.
What is different than last time is that this time the OBSS is going to stay behind on the station permanently, right?
That's absolutely right. And although we're doing the same task, the use of the OBSS for the subsequent mission is quite different. We were on STS-123. Our job was to get the boom up there so that the follow-on mission, STS-124, could use it to inspect their thermal protection system. And the reason for that was the Japanese lab was too big to hold the OBSS in addition, so we had to leave it up there so they could use it. This time, we're leaving the OBSS up there for future contingencies for the space station. And so it has sensors, for example, that are used to inspect the thermal protection system of the shuttle. We don't have to keep those alive, but what we do want to do is make it useful so it can be grabbed by the space shuttle or space station arm to extend the length of the arm to make repairs like what happened on STS-120 when they repaired the solar arrays that were torn. So we're not planning on using that thing on future ISS missions, but it's going to allow us to extend the space station arm another 50 feet.
And otherwise, during the spacewalks, then I guess you're involved in transfers and work of that kind?
Oh yeah, I'll be doing a lot of transfer during EVA 1 and 3. I'll also be taking photos. And you know, one of the most important things we do up there is taking photos. And people don't realize, you know, you don't have a press crew up there to take photos for you. So
not that they haven't volunteered to go.
And we've got an open seat.
Yeah.
So you got to put your name in the hat for that one. But we get a lot of training on photo TV in order to get the right shots in the right clarity and to tell the right story to document what we're doing up there. So, and I'm probably on the bottom half of my photo TV class, so I work really hard on getting all those settings right for the shots, and so I'll get to practice that when I'm on orbit as well.
During the rendezvous and docking on this mission, and then again after the undocking and the fly around, your crew's going to be gathering data for a development test objective that's known as STORM. That stands for Sensor Test for Orion Relative Navigation Risk Mitigation. This includes something that we've never seen before, a re-rendezvous with the station after the separation. You're going to be flying. Tell me what you guys are going to be doing here.
Well, the STORM test objective there is to basically analyze and evaluate a sensor system that could be used on a follow-on space vehicle. And so the final missions of any vehicle, aerospace vehicle, typically will be testing stuff that will replace that vehicle. Airplanes are have the same thing. And so we test future radars on the current airframes that have all the ability to, all the things around that sensor that you can analyze it with. So we're going to undock, and then instead of departing and coming back home, we're going to go out several thousand feet and then come back in and re-rendezvous with a totally different sensor. It's a whole unique array of burns. The trajectory is something very different than what we've ever flown before, but it's all in the same sorts of things that we've been doing with rendezvous, just looks different.
The pilot traditionally flies the separation and the fly around. Are you still going to be on the stick on the way back?
Oh, well, okay. Rendezvous, we typically aren't on the stick till you get very close. We do a series of burns, but we're not physically, the commander for the typical rendezvous isn't making a lot of inputs until we're within about a mile. And so a lot of this test is going to be outside of a mile. And actually we'll only get no closer than 600 feet, but typically when we practice it, we're about 800 or 900 feet away when we knock it off and then press on with our re-entry plans and all those sorts of things. But I will be flying the fly around, and I'll do the separation burns like we normally do, and then somewhere in there we'll swap roles, and Mark will be kind of watching out the back, and I'll be up front. But typically the pilot does a lot of those little burns. I won't be at the stick, if you will, but I'll be making some of the burns. But we're all working together to get the job done. Describe
the different approach that you're going to make this time. What's different about the way you're going to fly back than the way we are used to seeing shuttles approach the space station?
That's an interesting question, Pat. The trajectory that we normally see are a series of loops as we raise our orbit, and then we target a particular point underneath the space station so we can do our RPM, our rotation pitch maneuver, a rendezvous pitch maneuver that enables the station to take pictures of our tile. And then we come in and attach from the front. This particular trajectory, we just kind of go out in a straight line. We do the burn such that we're really just describing a straight line away from the space station, and then a straight line back in, and then just come up like this. So there's no loops or strange orbital adjustments or phase adjustments like we see on a regular rendezvous. It's more of a kind of a linear series of burns that bring us out and then back in. And frankly, I thought it was kind of interesting that they were able to design a trajectory that looked like a straight line out in space, because it's really hard with orbital mechanics to get that done. So you have to have the perfect burns to make that happen. And I have to leave that up for the scientists. You'll have to ask them about how they managed to do that.
As you noted, it's interesting that we're testing out stuff for new spacecraft on STS-134, which is the last scheduled flight of this spacecraft, of Endeavour. What are your thoughts about this ship's place in the history of the shuttle program, and the shuttle program's place in the history of human spaceflight? Wow,
that's a big question. Yes. Let's start with Endeavour. Endeavour's always been my favorite vehicle, and I guess because it's the newest of the vehicles. When I first became an astronaut a dozen years ago, one of my early jobs was to help prepare the vehicle and the crews for launch at the Cape, flipping switches, setting up procedures, taping things down. And so I became familiar with all of the different shuttles that I spent a lot of time in all of them. And Endeavour always looked the cleanest, it was the most pristine, and it was my favorite vehicle from the very start. And so, of course, my last flight I was on Endeavour, it was the 25th flight of Endeavour, and I was just tickled pink to be on Endeavour on my first flight. And I thought that might have been my only flight. And so then I get this flight, and I'm just amazed that I'm on Endeavour's last flight, potentially last flight. So yeah, I love Endeavour among the space shuttles. I love all the space shuttles, but I'm really happy to be on Endeavour's last flight. As far as the space shuttle's place within the whole manned space flight program, you know, the shuttle's been around for 30 years. We've done a lot of great work. We've helped assemble the space station. We've fixed the Hubble telescope, launched satellites, a lot of things that other vehicles just frankly couldn't do. It's our 18-wheeler in the sky. You know, we've got that big cargo bay. We take all big stuff up with us, and we've got the cab where all the people live and operate the vehicle. It's a one-of-a-kind spacecraft, and there's not an immediate replacement for it right now as far as a concept that will fill the bill of being a space shuttle. So I think it was an amazing vehicle, and I'm just thrilled to have been a part of that whole program. I do think it's been around a while. I think there are some design issues with the space shuttle system that have caused us difficulty. And so, like any aerospace system, it's time, our managers say it's time to move on to the next thing. And so out with the old and in with the new. So it's bittersweet. The shuttle's done a great job, but I also look forward to whatever kind of technology we have to replace it.
You're going to be flying this mission right around the 50th anniversary of the first human space flight, which is also the 30th anniversary of the first space shuttle flight, and the 50th anniversary of the first American space flight. What are your thoughts about the fact that you're going to be in space while we're all thinking about these historic milestones?
Well, that doesn't come to my mind as much as the fact that I guess I'm getting pretty old, because I was born not too far from all those things. I do remember watching the first lunar landing when I was 7 years old, so that's what comes to mind there. You know, Pat, I think milestones like 30th year, 50th year, last shuttle flight, those sorts of things are wonderful. It's wonderful to consider that I might be a part of a milestone, especially an amazing thing like manned spaceflight. But I think those milestones are kind of looking back. You know, you look back at those and you say, wow, that was cool. Like, I look back on milestones that my kids had, like the last time that they rode their bike with training wheels, for example. But that's not something that you really look forward to. So when I was at the time and my kid was on his last training wheel bike ride, it wasn't that big of a deal that it might be the last time they ride with training wheels. And so I guess with me, you know, all the shuttle flights that we've had are very important. And so being the last of a shuttle flight or the second to last of a shuttle flight or whatever, those milestones aren't important for a couple reasons. For one, because, and I don't mean to be, they're not important, but they're not on my radar because the last shuttle flight was STS-132. And right now, STS-132 is the last flight, and we don't take any flights for granted. And I'm hoping that we'll fly a few more shuttle flights, but we don't take this for granted. Every flight is a test flight, and so right now, STS-132 is the last flight, and then 133, you know, should they launch on schedule, they'll be the last flight, and then we'll be, and so, you know, maybe some quirk of fate will allow us to have even more shuttle flights.
On the one hand, then, you're going to be in space about 50 years after the first human space flight, and things have changed an awful lot from the days of Yuri Gagarin and Alan Shepard. So where do you think we're going to be 50 years in the future?
Wow, that's a great question. You know, I think in 50 years, I would be very surprised if we hadn't landed on another planet. Either the moon or Mars or heading toward an asteroid. I mean, I think that we're going to land on a surface. I believe that we will have learned, as we look back, a lot of new things that we didn't even know existed. And I think that space flight will be more commonplace. That's what I believe to be true. Just if you think about the airline industry back in the 30s, nobody was flying on airplanes, and 50 years later, on just a week's salary from a very basic job, you can fly from coast to coast. And so I think that space flight, although it's hard for us right now, we'll learn new technologies and new ways to do things, and it'll be easier and more common.